Now in this video we're going to start to work with pandas, and this is the package that's going to do all of the heavy lifting. We're going to get quite a bit of time with pandas here, and if it's not already installed, you'll need to install it at the command prompt, which you would install pip install pandas. Now it's already installed in this code space, but you may need to install it. Now, like Numpy, we're going to import the pandas module with an alias. So we're going to say import pandas as PD. So we're going to be using the PD alias. Now there are two fundamental data structures in pandas that we will be using. The first one that we'll talk about in this video is the series. And a series is basically a Numpy ndarray with an associated index. So let's create one. So I'll say S, short for series, pd.series, and then the initializer for the series is going to expect some type of data. And as you can see here in the IntelliSense, it is indicating that should be an ndarray or something like an ndarray. So let's look at another way to create an ndarray. So I can say np the random submodule and then randint, and this will return a ndarray of random integers. In this case, up to 1,000 is going to be the highest value, exclusive value rather. And then I'm also going to pass it a size keyword argument, which is going to be a tuple with the dimensions. So I'm just going to say 10. Now, I can't use a multi-dimensional ndarray with a series because they are one-dimensional. But you can use the randint function to create multi-dimensional data if necessary. But here we're just going to have 10 random integers from 0 to 1,000 exclusive. So let's look and see what that looks like. Now, the numbers on your end are probably going to be different than the numbers on mine, but what you can see here is these are the values that were generated by the ndarray, and this is the associated index. By default, the index will start at 0, and it will be integers in ascending order. In fact, we can look as if we say s.values, we can see that ndarray that is storing the values. Okay, let's look at another one. Let's import the string module from the Python standard library, and then let's create a series, PD series again. And this time I'm going to get string ASCII uppercase, which is just a string with all of the uppercase letters in it. And what I need is I want to put that into a list again. This is another place where you can use a list and a Numpy ndarray in the same place. And now if I look at the value of that, I'm going to see that I have all the letters A through Z, and then I have the associated index 0 through 25. However, we can actually use different values for the index. We don't have to have just integers. Later on, when we get into pandas more, I'll show you how you can have what's called a multi-index, in which you can use multiple values for an index. But one of the more popular types of indexes that you'll use is a date-time index. So let's create one of those. So I'm going to say idx equals pd.dateRange. And dateRange is going to expect, first of all, a starting date. And I can pass in a string representation in year, month, day format. So let's start with 2025, January 1st, 2025. Then I'm going to tell it periods. Basically, how many values do I want to be in this index? Well, I have this series, and I want to have one for each value in the series. And then the series is backed by a Numpy ndarray, and I can get the length of a Numpy ndarray using the built-in len function. Well, can I do it with a series? Turns out I can. So this is going to return the number of values in that series. And periods is the keyword argument for that. Then I'm going to tell it the frequency. This is essentially the interval between each value in the date-time index. And for this, we're going to use D. That's daily. So let's take a look at IDX here. And you can see that we have the first 26 days of January. There's actually a whole mini language that you can do for this. So for example, if you say ME, that's going to be monthly. And then you can even do, and so each one is the last day of the month. You could even do YE for yearly. And notice this, it's the last day of every single year for the next 26 years. But notice down here that by default it uses this YE-DEC. I can come up here, I could say YE-MAR for March, and every one of them will be the last day of March instead. So, like I said, there's an entire mini language here that you can use, but we're just going to stick with days for this example. All right, now what I can do is I can recreate that series. I can say PD series. Again, list, whoops, string ASCII uppercase. And this time I'll tell it to use IDX, rather, as the index. Here's the value of that. Whoa, what happened here? Oh, I did not assign that to S. There we go. So now you can see each one has a date associated with it. So now I could say, okay, what's the value for January 10th, 2025? So say 2025, 0110, and we'll see if the value is J. Or what I can do is I can actually slice the index. This is very useful with a date time index, because I can now say what are the values for a particular date range. So I can say like the 10th through the, if I can get the year right here. Well, okay, let's try that again. 1/17, so the 10th through the 17th. This is very powerful, very useful here. And like I said, later on we'll see a multi-index. But for now, that's enough about Pandas series. In the next video, we will start to look at the other data other data structure that we will use, the fundamental data structure we'll use in Pandas, the data frame.